Understanding Magnetic Circuits, a comprehensive guide. Hello everyone. Today, we're going to explore a fascinating concept from the world of physics and engineering: magnetic circuits. Just like an electric circuit controls the flow of electricity, a magnetic circuit guides magnetic fields. This video will break down this complex topic into digestible parts, making it easier for you to understand and apply this concept. Imagine a path that magnetic fields travel along. This path, known as a magnetic circuit, is not much different from an electric circuit. However, instead of electrons moving through a wire, we have magnetic flux flowing through materials like iron or steel. These materials are chosen specifically for their ability to channel magnetic fields effectively. Just like any circuit, a magnetic circuit has its own set of components. Magnetic flux, phi. Think of this as the total amount of magnetic field flowing through the circuit. Magnetic field strength, H. This measures how strong the magnetic field is in a material. Magnetic permeability, mu. This is a property of the material that tells us how well it can support the formation of a magnetic field within itself. Magnetic reluctance, R. Similar to resistance in an electrical circuit, reluctance is a measure of the opposition to the flow of magnetic flux. Magnetic circuits operate on some basic principles. Ohm's law for magnetic circuits. Just as Ohm's law defines the relationship between voltage, current, and resistance in electrical circuits, it also applies to magnetic circuits, relating magnetic flux, phi, magnetomotive force, mmf, and magnetic reluctance, R. Magnetomotive force, mmf. This is the force that drives the magnetic flux through the circuit. It's comparable to the voltage in an electrical circuit. Magnetic circuits are not just theoretical concepts. They have practical applications in everyday devices. Transformers. They rely on magnetic circuits to transfer energy between different circuits. Motors and generators. These devices use magnetic circuits to convert electrical energy into mechanical energy, and vice versa. Inductors and relays. These components in electronic devices also utilize magnetic circuits to function properly. Understanding magnetic circuits can seem daunting, but it's a crucial concept in both physics and engineering. It's fascinating how they are analogous to electric circuits, yet unique in their operation and applications. We hope this video has illuminated the concept of magnetic circuits for you. Stay curious, keep learning, and until next time, happy studying.